Once we get through today's activities, then the focus really is going to shift to entry. And I think the first graphic is important to show up here for some of those critical events. You know, the first one that we're really going to have to keep our eye on is crew module and service module separation. That's going to happen about 20 minutes before entry interface. Once we get through the separation of the service module, we're going to do one final burn. It's called our crew module raise burn. This is typically not a burn that's going to be required, but it's our final opportunity to fine-tune our flight path angle before entry interface. So we'll perform that about 16.5 minutes before entry interface. Once that burn is complete, the spacecraft is going to make a couple of roll maneuvers. This will provide additional separation between the service module, which is headed for a destructive entry in the Earth's atmosphere, from the crew module, which obviously contains our 4 astronauts. Once those rolls are complete, the crew will go visors down, and then they will be in a isolated environment in their launch and entry suit until after splashdown. We'll hit entry interface at 400,000 feet, about 1,950 miles away from our landing site, and that's when the fun really begins. The 24 seconds after entry interface, we'll hit our blackout, which is the point at which the plasma has built up around the spacecraft such that it interferes with our ability for the transmitters on Orion to transmit telemetry. This is nominal. It'll last 6 minutes. Once that 6-minute blackout is done, Orion's going to be at about 150,000 feet. So still falling pretty quickly. We're going to be within a couple tens of miles of the landing site by that point. And then our focus is going to shift to deploying the parachutes. We've got 2 drogue parachutes that'll deploy. It'll be about 22,000 feet. That'll slow us down to about 200 miles an hour. And then we'll deploy the 3 main parachutes. Those are the orange parachutes you see in the image. That'll happen about 6,000 feet altitude, which will slow the spacecraft and her 4 inhabitants down to a gentle 20-mile-an-hour splashdown in the Pacific Ocean. We'll get the spacecraft power down about 15 minutes after splashdown, and then I'm going to hand over to Lily Villarreal, our recovery director, for mission authority. Let's go to the next graphic, which has a little bit more detail on some of those events. Here's a plot of what entry is going to look like. You can see it's only 13 minutes from entry interface until splashdown, so it's going to happen pretty quick. And the flight control team here in Houston, we're going to be without comms with the flight crew for 6 of those minutes. So it's going to start quickly, and it's going to be over even faster. Next page. And then for a graphic of all the parachutes that are going to deploy, the first thing before we deploy the drogue parachutes, we have to jettison something called the forward bay cover. It provides the protection for all the parachutes, and that's what's going to get jettisoned at about 35,000 feet. There's a window for the jettison of the forward bay cover, so if it doesn't happen at 35,000, it can happen lower, as low as 24. And nominally, we actually expect it to happen closer to 24,000 feet. Next page. And then if you're looking for a little bit of insight on our approach trajectory, we're going to have entry interface a little bit southeast of Hawaii. And after we fly 1,957 miles over the surface of the Pacific Ocean, we'll be landing in our targeted landing site off the coast of California.
Second graphic I have is a few days ago I showed you some imagery of the crew module images we got down from our first external survey that was right after the TLI burn. So we actually do another external survey on the way home. This is our inbound external inspection. So I think at the next slide. Yeah, so this is kind of 2 different views of the spacecraft. Again, did a comprehensive review of all the imagery that we were getting down off the surface of the crew module. No concerns, no issues seen that would make us have any pause for the reentry phase. Everything is in excellent condition for that entry. So that's our pretty crew module. I think we have a couple of pictures of the service module as well. Yeah, so we obviously don't bring the service module home. As we mentioned, that gets separated about 40 minutes before splashdown. But we did get some nice imagery. And the next one I thought was interesting. It's a picture of the solar arrays, but it's actually the backside of the solar array, which we don't normally see. So anyway, poured over all this imagery, and everything looks really good for the return. Operations-wise, there's a few other things going on in the cabin. One interesting test that we're doing today is when you pressurize the cabin, the panels and things that are connected there, kind of shift around a little bit. And so we're having a demonstration of, can you actually remove some fasteners in those panels and put them back in? Do the structures still line up enough that you can do that? This is to help us prove out if we needed to do any kind of maintenance or contingency access to like our ECLA system. So we'll be looking at that today to see if that demonstration works out well. We're also doing some demonstration, what's called 20 by 20 degree dead banding. This is pointing the spacecraft a little bit different throughout the day to test thermal responsiveness of the systems externally to see if we can expand our operating envelope for future missions. So I guess some other things, we've collected a lot of data on this mission. We'll be getting a lot of that data back when it comes back, but did want to mention a couple things. We've consumed 2,964 pounds of fuel in the service module. We have 4,285 to go. So clearly we had put a lot of margin into this mission to make sure we could fly it properly. 9,855 commands have been uplinked, so been busy for the flight control team and the MER team doing all of that. And then we mentioned the optical comm and how effective that has been in getting data down. 122 gigabytes of data downloaded. That was a record. That was in a single day. That was today. And a total of over 312 gigabytes of data coming down on that optical comm system. So that's been really helpful for us getting down some of this beautiful imagery. Cabin is currently at a 76 Fahrenheit degree, so the crew's quite comfortable. Everything looks really well. And I think that's probably it from me. Spacecrafts continue to operate nominally, and we are hard at work monitoring it until it gets home. So with that, I will hand it over to Lily.
Okay, great. Thank you for joining us today. I'm currently at sea aboard the USS John P. Murtha with the joint NASA and military team who are ready to safely recover the crew once they splash down off the coast of California. The ship departed from Naval Base San Diego on time, and we are currently maneuvering the ship to the landing zone. Over the past couple of days, we have been completing final preparations on the ship, including training with the joint NASA and military team to refresh the skills and procedures that we've been practicing during underway recovery tests. I want to quickly walk you, however, through the process of how we will safely recover the Artemis II crew and the Orion spacecraft once they return from their trip around the moon. The ship and the small boats will be positioned at a safe distance at splashdown until the team has determined that their path of travel will be clear of any of the jettison hardware that Rick talked about. At splashdown, the crew in Houston will follow their post-landing procedures while our divers maintain a distance of about 120 yards to the capsule once we're cleared to go to the capsule. After handover from the flight director to the landing recovery director, the divers will approach Orion and they will conduct assessments of the air and water surrounding the capsule just to make sure that it's safe to approach and help the crew exit Orion. After ensuring the area is safe, they're going to go ahead and open the Orion hatch and help the astronauts from their seats to a large inflatable raft that we call the front porch. Once all 4 astronauts are on the front porch, we will tow the capsule away from the front porch, and the team will pick up from Navy helicopters, which are deployed from the recovery vessel. 2 helicopters are going to rotate, picking up all 4 crew members before they return to the recovery ship within a few minutes of each other. Once the crew has exited the helicopters, they will proceed to the ship's medical bay to undergo routine post-flight medical checkups. We expect to recover the crew and deliver them to the medical bay within 2 hours of splashdown. With the crew safely out of the capsule and in tandem to the recovery, teams will work on towing Orion into the well deck of the ship using procedures that were very similar to those that we used on Artemis I. Once we have Orion safely inside and all the small boats are back on the ship, we will start making our return to Naval Base San Diego. Depending on our distance, by then the Artemis II crew will fly off the ship back to shore, we anticipate within 12 to 24 hours post-splashdown.